that. So anyway, we're going to go to Japan. We're going to go nuclear here. And look at an example. Many of our examples involve Excel being used in some way or another. And what we learned as we toured the world looking for FME uses is that in many ways, Excel is the shapefile of non-spatial data. It seems like it pops up everywhere, and people are always doing stuff. So this particular example from Japan is interesting. I mean, it's a bit sad, but it's nice to see FME being used in a way to help a very sad situation. And what's going on here is using FME in a way to help estimate the amount of radioactivity in a variety of agricultural water supply areas so that you can figure out ultimately where we shouldn't be growing food and where we can. And so we're using FME to interpolate this data. And so what is this data? Really, it's an Excel file of observations of how much cesium concentration is in a variety of locations measured in X and Y. And what we're doing is just creating a surface out of that to interpolate or to figure out or guess what the cesium concentration will be in other places where we didn't measure. And so I guess the interesting trick here is that FME has always been able to create a 3D elevation model, and it's nice to be able to use Z again instead of Z. So anyway, where normally the Z value is what we use as input to the model, and we can create a terrain model for what we think the Earth looks like. But in this case, instead of putting Z in there, we'll put the concentration of cesium in there. And so we'll create a model that isn't of the Earth that we can observe, but an imaginary or synthetic model that is of the cesium amounts as we look over the whole area. So we create that surface model, and now once we've got it, we can then make at least a reasonable interpolation or a guess as to what the cesium would be anywhere that we didn't actually have an observation. And so then we overlay these on top of our irrigation ponds and figure out what ponds are bad and what are not. So there's two ways that this is done, through these different polygons that are called Thiessen or Voronoi polygons, as well as Delaney ones. And perhaps the best is just to show you these kind of things. So here's these dots would be where we have actually got measurements. These ones in the middle are the centroids of those things, and we're figuring out how much cesium would be in these various water bodies and agricultural areas. And so, and so basically, in the end of all this, they're able to give advice to the local farmers and avoid basically contamination in the food supply. So kind of a nice to see FME being used to basically help, although it is kind of a sad story. So